Hello viewers, in today's session we are going to discuss an important problem from integrals, and here we are going to discuss this problem where we are given a function f which is from r to r, where r is the set of real numbers such that f of x is equal to the integral 0 to x t square f of t dt plus x cube. And if this function f of x is differentiable for all x belonging to the set of real numbers, then we have to find f of x, right? So here we will apply the Leibniz integral rule to find f of x. So let us start. So here we are given f of x is equal to the integral 0 to x t square f of t and dt plus x cube. Now let us differentiate both sides with respect to x. So we have d by dx of f of x, and here we have d by dx of this integral 0 to x t square f of t dt, and then we have to differentiate x cube with respect to x. So we are given the function f of x in this form, and let us differentiate both sides with respect to x. So here d by dx of f of x is f prime of x, and here we have the derivative of x cube as 3x square. Right now, to differentiate this integral with respect to x, will make use of Leibniz integral rule. Right now, see, if we have a function, say f of x is equal to the integral, say a to x, and here we have a function, say g of t dt, then the derivative of f of x, that is f prime of x, is equal to simply g of x. That is, we replace this t by x, right? So here we have this integral, right? And if we compare this integral with this one, then the value of a is 0, and here we have x, here also we have x, and for g of t we have t square f of t. So the derivative of capital F of x, that is f prime of x, is simply equal to g of x. So here, applying this rule to this integral, we have simply or we have to simply replace all these t's by x. So we have now x square, and here we have f of x. So now we have the expression for the derivative of f of x as f prime of x is equal to x square, and here we have f of x plus 3x square, right? So now we have a differential equation, and we have to solve this differential equation. So what we will do, we'll write f prime of x, we can take x square common, so we have f of x plus 3, right? Okay, so now we can write here separating the variables. Here we can write f prime of x divided by f of x plus 3, and here we have x square. Now let us integrate both sides. So we have integral f prime of x dx, and here we have f of x plus 3, and here we have integral x square dx, and c is the constant of integration. So now to find the integral of this entire integrand, we can make use of the method of substitution. So let us take a u is equal to f of x plus 3. Now a du over dx is equal to f prime of x. So differentiating both sides with respect to x, du over dx is equal to df over dx, that is f prime of x, and the derivative of 3 being a constant is 0. So we can now write du is equal to f prime of x and dx. So now for f prime of x dx, we can write du, and for f of x plus 3, we can write simply a u. So we have the integral du over u, and here the integral of x square is x cube over 3, and c is the constant of integration. So here we have applied this rule, that is integral x raised to n dx is equal to x raised to n plus 1 over n plus 1, provided n is not equal to minus 1. So now we have integral du over u, and the integral of 1 over u with respect to u is the natural log of u, and here we have x cube over 3 plus c. Now let us replace this u by f of x plus 3. So we have natural log of f of x plus 3, and here we have x cube over 3 plus c. So now we need to find out the value of this constant of integration c by using some initial condition. So now let us take x is equal to 0 in this equation. So we have f of 0, and then we have 0 to 0, and here we have t square f of t dt, and x cube is 0 cube. Now f of 0 is equal to 0 plus 0, because here the limits of integration, both the limits of integration are 0, so the value of this integral is 0. Here we have 0, so we have 0. So when x is equal to 0, that is f of 0 is equal to 0. So let us apply this condition to get the value of c. So let us take x is equal to 0 in this equation. So we have now natural log of f of 0 plus 3, and here we have 0 cube over 3 plus c. Now this is natural log of f of 0 is 0. So here we have 0 plus 3, and this term is 0, and here we have c. So natural log of 3 is equal to c. So the value of the constant of integration c is equal to a natural log of 3. So now let us substitute this value of c in this equation. So we have log of f of x plus 3 is equal to x cube over 3 plus a natural log of 3, right? Now taking natural log of 3 to the left hand side, we have natural log of f of x plus 3 minus natural log of 3 is equal to x cube over 3. Now applying the properties of natural log, we have here a log of f of x plus 3 divided by 3, and here we have x cube over 3. So here we have applied this rule, that is natural log of a minus natural log of b is equal to natural log of a over b. So using the properties of logarithms, we have now this expression. So now natural log of f of x plus 3 over 3 is equal to x cube over 3. So now removing this natural log, we can now write f of x plus 3 over 3 is equal to e raised to x cube over 3. right? And multiplying this term by 3, we have f of x plus 3 is equal to 3 times e raised to x cube over 3. And now we can take this 3 to the right hand side. We have 3 times e raised to x cube over 3 minus 3. And taking 3 common, we can now write 3 times e raised to x cube over 3 minus 1. So this is the required expression for f of x. So now from this expression, we can also find out the derivative of f of x. So f prime of x is equal to 3 times the derivative of e raised to x cube over 3 minus 1. So f prime of x is equal to 3 times. Here the derivative of e raised to x cube over 3 is the exponential function itself, and then by chain rule the derivative of x cube is 3x square, and in the denominator we have 3, and the derivative of 1 is 0. So now this 3 and this 3 get cancelled, so f prime of x is equal to 3x square e raised to x cube over 3. So this is the required expression for the derivative of f of x. Hello viewers, in today's session we are going to discuss an important problem from derivatives, and here we are going to solve this problem where the integral 0 to x f of t dt is equal to 2x cube minus integral 0 to x square f of t over t dt. Then we have to find the value of f of 1, right? So let us see how we can find out the value of f of 1 using Newton-Leibniz theorem. So let us first quickly see the statement of Newton-Leibniz theorem, and then we'll apply the same to this problem. So now consider this integral where the limits of integration are some functions of x. So here the lower limit is u of x and the upper limit is v of x, and now consider a function, say f of t, which is a continuous function in some interval, say a comma b, right? And let us differentiate this integral with respect to x, right? So here u of x and v of x are some differentiable functions of x. Then the Leibniz integral theorem says that d by dx of this integral is given by f of v of x. That is, first we'll replace this t by v of x, and then we write here d by dx of v of x, and then we have a negative sign. Then we have f of u of x, that is, now we'll replace this t by u of x, and we multiply this expression by the derivative of u of x, right? So now we have to differentiate this integral where the lower limit and upper limit are some differentiable functions of x. So d by dx of this integral is given by f of v of x, then the derivative of v of x with respect to x minus f of u of x multiplied with the derivative of u of x. So now consider the special case when the lower limit, that is u of x, is equal to 0, right? In the given problem here we have the lower limits as 0, right? So if u of x is equal to 0, then we can modify this statement by writing here f of v of x and d by dx of v of x, and here since u of x is equal to 0, so this entire term reduces to 0. So here now we have d by dx of the integral from 0 to v of x, and here we have f of t dt, right? So whenever we have an integral of this form where the lower limit is 0 and the upper limit is some function of x, that is v of x, then the derivative of this integral is simply given by f of v of x, that is will replace first this t by this upper limit, that is v of x, and then we multiply this expression by the derivative of v of x. So let us apply this result to this problem by differentiating both sides with respect to x. So now differentiating both sides with respect to x, we have d by dx of the integral 0 to x and f of t dt, and then we have d by dx of 2x cube, and then we have d by dx of the integral 0 to x square f of t over t, and here we have dt, right? So now if we compare this integral with this one, then v of x is simply x. So applying this result to this integral, we have here for f of t as small f of t. So now we have simply f of x here and the derivative of v of x, and v of x is simply x. So the derivative of x is 1, right? And here we have 2, and the derivative of x cube is 3x square, and here v of x is now x square. So we'll replace all these t's by x square, that is f of x square over x square, and then the derivative of v of x. So we have here d by dx of x square, right? So now here this term is equal to 1. So we have simply f of x here multiplied with 1. Then here we have 3 times 2 is 6, 6x square, and here we have f of x square over x square, and the derivative of x square with respect to x is simply a 2x. So now we can write f of x. Here we have 6x square minus f of x square. Here we have 2 and divided by x. So here this x and this x get cancelled, right? So now we have this expression, that is f of x is equal to 6x square minus 2 times f of x square over x. Now we need to find out the value of f of 1. So let us replace x is x by x is equal to 1. So here we have f of 1. Then here we have 6 times 1 square. Then here we have 2 times f of 1 square over 1. So we have f of 1. Here we have 6. And here we have 2 times f of 1. 1 square is 1. Right? So now we have a linear equation in f of 1. So taking this term to this side, we have f of 1 plus 2 times f of 1 is equal to 6. So this is 3 times f of 1 is equal to 6. F of 1 is equal to 6 over 3, that is 2. So the required value of f of 1 is equal to 2. So viewers, this is how by making use of Newton-Leibniz integral rule, we can find out the value of f of 1, and the value of f of 1 in this case is equal to 2.